Okay, so here was our second test over lots of rational type functions. Okay, so that's what these questions are about rational. So first of all, we're given this equation and asked, what is the slant asymptote? Okay, so notice this is a top-heavy function, right? We have an x to the fourth on top, but only an x cubed on the bottom. So it's top-heavy, so there's no horizontal asymptote. So we can calculate the slant asymptote by doing long division. Okay, so you put your denominator on the outside, and then we put our numerator on the inside, accounting for every power. So there's no squared power, there's no cube power, so we put in zeros, we have a linear, and we have a constant. Okay, so when we're missing a power from your equation, you have to put in a 0. So our thought process is 2x cubed times what value gives us 4x to the fourth. Okay, and that would be 2x. So if I multiplied 2x by 2x cubed, I get 4x to the fourth. But I also have to multiply it here by this one, which is minus 8x to the third. Okay, so our algorithm for long division is subtraction, so we change the signs, and I end up with an 8x cubed and then a plus 2x. We'll see if I need it. So we go back and we ask ourselves, 3x cubed times what is 8x cubed? And that answer is a positive 4. Okay, so once we have our linear equation, in this case a linear, we can stop doing our math because that's the equation of our slant asymptote, 2x plus 4. Okay, kind of tricky there to remember all that stuff sometimes. Okay, the next question says, for what values does the y equal 0? Okay, so number one, anytime we have a rational function, we need to factor it. So the top factors to x minus 5 and x minus 2. And the bottom factors to x and x plus 2. Okay, right? This is a common factor, not a quadratic factor. And we look and see that no, in fact, nothing does cancel, right? Nothing cancels out. Because if something cancels, that's not part of your solution. So your y values or your x-intercepts come from your numerator. Okay, so these are talking about your x-intercepts. Where does it cross your y-axis? That happens in your numerator. So we would cross at 5 and at positive 2. So those are the values where f of x equals 0. Right? Those are your x-intercepts. Now, your denominators. This tells you where we have a vertical asymptote. So we have a vertical asymptote at 0, and we have a vertical asymptote at negative 2. Okay? So this function doesn't have any holes. It has 2 x-intercepts. It has 2 vertical asymptotes. And that's an important thing. Notice this is a neutrally heavy function. We have x squared over x squared, which means we have a horizontal asymptote at y equals 1, because it's 1x squared divided by 1x squared. 1 over 1 is 1. Okay? So that's an important thing. Those are all the things that we could do about an rational function. Okay? So our next one, what about the limits? So we have a couple of different limits. We have your horizontal asymptote, right? Your limits to infinity. We have vertical asymptote limits, and potentially we have a whole limit. So first, horizontal asymptotes. That's the limit as x goes to negative infinity, and the limit as x goes to positive infinity. So horizontal asymptotes come from your heaviness. So notice this is a neutrally heavy function. We have x squared over x squared. It's neutral. So we look at the coefficients. X squared divided by x squared is 1. So your horizontal asymptotes always have your same end behavior, right? This is the end behavior of a rational function. What's going on to the far left and the far right of your graph. Okay? So now let's look at our other ones, our vertical asymptotes. So to do that, we need to factor. So this factors to x minus 7 and x minus 1. And the bottom factors to x plus 1 and x minus 1. Okay? Anytime you see a rational with a quadratic, you need to think about factoring it. So here is your whole. Anytime we have something that will cancel out, will divide, that's where we're going to have a whole. So let's talk about the whole's limit. So that would be here. We're talking about the limit as x approaches positive 1, right? That's the x value of our whole. Okay? And what the answer is the y value for your whole. So we need to figure out what the y value is. Well, to do that, we plug positive 1 back into our equation of what's left, right? This is called your simplified expression. So x minus 7 over x plus 1. If we plug a 1 in there, and that 1 comes from here, right? That's the whole. We get 1 minus 7, which is negative 6 over 2. Negative 6 over 2 is negative 3. So for the limit for our whole, the x approaches is the x coordinate for your whole, and the y answer is the y coordinate for your whole. Now, the last limit is for your vertical asymptote. Okay, the vertical asymptote is the thing that didn't cancel out. So we have a vertical asymptote at x equals negative 1. Sorry, that's some bad math. X plus 1 equals 0. So we have a vertical asymptote at negative 1, which means we have to have a two-sided limit. So negative 1 from the left. Okay, we find that limit. And we find the limit as x approaches negative 1 from the right. Okay, this is where you have your left side limit and right side limit only for a vertical asymptote. Because we need to know, is our graph going up or is our graph going down? So there's x equals negative 1, there's your vertical asymptote. So we plug in a number a little bit to the left. So plug in negative 1.1 into our function. So we have a negative number on top and a negative number on bottom, which means our limit goes up to infinity because we have a positive value. And then plug in a number to the left, so 0.9. Negative 0.9 minus 7, negative 0.9 plus 1. We have a negative over a positive, which means we have a negative value and your graph goes down. Okay? So those are your limits of vertical asymptotes, the limits of a whole, and the limit to infinity for your horizontal asymptote. Okay? Make sure you know the difference between those three things. And then our last little section from your third test, right? Horizontal dilations. So if we have a 4x in our parentheses, that means we have a horizontal dilation by a factor of 1/4. Okay, because parentheses always are not truth tellers. So if we have multiplication in our parentheses, that means we actually have a division of your dilation. Okay, and then if we had a minus in your parentheses, right, we're moving that 4 units to the right. So this is a right 4-unit translation because our parentheses don't tell us the truth. Everything outside is the same, but on the inside they are opposites. And then know how to manipulate a domain in a range from a transformation. So say we have M. Let's say that is your transformation. Okay? And maybe we have a domain of negative 3 is less than x is less than 5. There's your domain, and your range, let's say, is 1 is less than or equal to y is less than or equal to 10. So there's your domains and your ranges. So the domain adjustments happen inside of your parentheses. Okay? So it says 1/2, so you're going to need to multiply by 2 and then add 3. Because this moves our graph to the right, and this does the opposite. So we're going to multiply -2, -3 times 2, which is -6. And then we're going to add 3, giving us back to -3. Okay, multiply 5 by 2, that's 10. 10 plus 3 is 13. So there's your new domain. Now the range is affected by the stuff outside of the parentheses. So we're going to multiply it by -2, and then we're going to add 2 to our y values. So 1 times -2 is -2. -2 plus 2 is 0. And then we're going to change our inequalities. 10 times -2 is -20. -20 plus 2 is -18. So when you multiply by a negative, you change your inequality signs. Okay, so there's a little review about Unit 2 test. And then Unit 3 was all about using the calculator and finding residuals and regression models. Okay, hopefully this helps. Go be great.